Okay, so welcome back to lecture once again, guys. Now, we'll try to do a little bit of postmortem in this lecture of a neural network, and we'll try to show you that how the weight and the biases looks like layer by layer, layer by layer. Let's try to understand that. So in my previous example, so I was talking about this, and I have already shown you a layer by layer this diagram, or you can say a layer by layer details. Now, so let's suppose I have this model which I have already created, and obviously if this is the neural network, right, this is the neural network. So if I have a input layer and then if I have a hidden layer, so we know that input layer will be connected, or one neuron will be connected to all the neuron available inside this hidden layer, and there will be a weight, right? There will be a weight W1, W2 and so on, plus there will be a biases that we try to attach, right? We try to attach a biases. Now randomly it is going to initialize a weight, right? If we are not going to initialize from our side, so randomly it is going to initialize the weight. So how we will be able to check that what is the weight? And even like in every layer, so we try to train the model. So in every layer also you will be able to see the weight after the training. That is also possible, right? That is also possible. So let me show you how to check a weight. So here I can try to call model that I have created dot there is something called as layers, right? So first of all, get layer, and let's see what it is going to yield. Get layer, yeah. So this is going to give me just an object, and here I'm not going to call get layer, by the way. I'm going to call layers, let's suppose. So this is the layer that we have: input layer, and then dense layer, and then dense layer, and then dense layer. Fine. Now, so let's try to call only a layer 1. Fine. Let's try to call only a layer 1 over here. Now I can try to check what is a weight, right? I can try to check what is the weight. I can even try to like set the weight. I can try to even call a trainable weight. Each and everything I will be able to plot, and I will be able to print. So first of all, let me call basically a WEIGHTS weights. So here you must be able to see the weights, right? You must be able to see the weights. Now if you are going to look closely, so we have 4 such weights, or 4 such array we have over here. So one will be connected to 10. So here in the very first one, if you will check the number of values, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 we have. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It should be 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe, okay, on this side. Sorry. Okay. That's the reason I was just assuming that why it is showing me 9, because it should show me 10. So yeah, it is showing me 10, right? So it is showing me 10. So 10, 10, 10 and 10. So here, so this 10 we are able to see for this one, for this one, for this one, and for this one. So this is the weight W1 to all. Now for this W1 to all, for this W1 to all, and for this W1 to all. So weights we are able to see very clearly, right? Very clearly that this is the weight which has been initialized internally, right? Now similarly, so for layer 1 I am able to see the weights. I can show you a weight even for a layer 2. So for a layer 2, I can show you the weight. So here 10 is to 8, right? So 10 is to 8. So here we have a 10, and everywhere you will be able to find 8. 1, 2, 3, 4, 5, 6, 7, 8. So 10 neuron connected to the 8 neurons. Simple. 10 neurons connected to the 8 neuron. So now if I'm going to draw this entire neural network in a clean way, so 1, 2, 3, and 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, right? And now this one is connected to all of this one, and we are able to see a weights. We are able to see a weights. Now this one is connected to all of this one. Yeah, all of this one. Now this one is connected to again all of this one. So what I'm trying to show you over here is that it's not a black box that we are talking about. We are talking about something which you can visualize. So now this one is connected to all of this one. Yeah. So this is how the first layer looks like. And we were able to see all the weights for the first layer. So there will be an input. Let's suppose we have x1, we have x2, we have x3, and we have x4. Technically, it's a sepal length, sepal width, petal length, and petal width as per our data set. Now, this 10 will be connected to rest of the 8. Yeah, this 10 will be connected to rest of the 8. So we are able to see even a weight for that one. Everything which we have studied, we can try to visualize it. Everything means literally everything. And we will be able to get the exact data as well. So it's technically not a black box that I'm talking about. Yeah. I think now it looks pretty much colorful to all of us. Okay, so many lines, so many lines. Yeah. So, and finally, like, this one, right? And finally, I will be able to get the output. So this is like a kind of a neural network that we are creating over here. So now we can visualize even this layer weight. So this is my layer 1, this is my layer 2, and this is my layer 3. Now for each and every layer, I'm able to show you a weight. So for layer 2, I'm able to show you a weight. Similarly, so in layer 3, so we have 8 cross 3, right? 8 cross 3. So we have 8 cross 3. So we have like 8 neurons over here, and then it is trying to go towards 3 neurons. So here 8 cross 3, and you can see the weight, right? You can see the weight. So we have basically 8, and then to all 3 it is connected, and we have a weight over here. Now similarly, you can try to even check a trainable weight. So trainable weights you will be able to see. So as of now, my weights and the trainable weights is completely same, right? So this is the weight it is going to eventually change. So once it will start learning the relationship, very simple, right? It will start learning the relationship. So here trainable variable, if I'm going to call, so these are the trainable variable, trainable weight, parameter variable, all these things are exactly going to be same. So you will not be able to find out any kind of a differences. Now let's suppose if I have to like show you a bias. Yeah. So bias. So bias is what? So 3 biases, 0, 0, 0 for third layer. Now for a second layer, if I have to show you the biases, so what is the bias which is initialized? So there are 8 biases, right? And then if I have to show you maybe for a layer 1, so there will be 10 biases, and value of those biases is what? Value of those biases is actually 0. So for weight, we are able to get the value. For biases, we are able to get the value. So now this neural network parameters are not at all unknown to me. I know my input, I know my initial weight, I know my activation function, I know my biases over here, I know my output, I know each and everything technically. Yeah. And even I'm able to visualize my model layer by layer, layer by layer. Very simple, right? Very simple. So hope this makes sense, and this is going to give you a lot of clarity that what happens inside a neural network whenever you are going to create it. And hopefully we are able to decode a neural network, right? We are able to decode a neural network, that what is a weight and what we are going to change, what we are going to change, and layer by layer, even inside a backward propagation. So whenever you are going to change the weight, just call the layer dot weight, and you will be able to see the latest value of the weight, right? So everything is a mathematics, by the way. Everything is mathematics, and everything you will be able to see it. So with that, thank you so much, everyone. Take care, and see you again in my next chapter.